Hi, this is Rajnikant Mishra. Today we are going to discuss one of the most important topics of logical reasoning, the clock. But before it, let's take a quick view of previous chapter, the calendar, in which we discussed about leap and non-leap year, concept of odd days, the Gregorian calendar, day calculation from date, and top 20 calendar MCQs with solutions. Let's take an example. Find the day on 25th of April, 1868. If you know the concept of calendar, then you can easily say it was Saturday. The link of this video is given in the description box. Now, topic of the day, the standard clock. It is a standard clock. This hand is known as hour hand. This one is minute hand, and this one is second hand. We know the rotational speed of hour hand is minimum and of second hand is maximum. In a day, there are 24 hours. And in 1 hour, there are 60 minutes, and in 1 minute, there are 60 seconds. Here, this circular dial is divided into 60 equal parts, and each part is known as minute. Here, this small portion is known as 1 minute. So, in a day, there are 86,400 seconds, 24 hours, 60 minutes, 60 seconds is equal to 86,400. Here, this complete angle is 360 degree. So, the angle of 1 minute is equal to 360 by 60 is equal to 6 degree. It means this angle is 6 degree. In 1 hour duration, this hour hand moves from 12 to 1. Here, this angle is equal to 5 into 6 degree is equal to 30 degree. It means hour hand covers 30 degree angle in 1 hour. So the speed of hour hand is equal to 30 degree by 60 minute is equal to 0.5 degree per minute. But this minute hand covers whole 360 degree rotation in 1 hour. So the speed of minute hand is equal to 360 degree by 60 is equal to 6 degree per minute. Angle between hands of a clock. Here there are two conditions. In first condition, the minute hand is behind the hour hand, and here the minute hand is ahead of the hour hand. Here we will measure the rotation of these hands from this reference line. Here x represents the rotation of minute hand and y represent the rotation of hour hand. Here this y minus x or x minus y is the angle between these two hands. Let this angle is theta. Now we are going to derive a formula for this theta. Find the angle between the hour hand and minute hand at time h hours m minute. You can write it as 4 hour 20 minute or 5 hour 30 minute. Means m represents minute and h represents hour. First, we are going to find the value of y, means rotation of hour hand. For easy understanding, let the time is 5:10. In 5 hours, the hour hand moves from this position to this position. First, we have to find this angle which is covered in 5 hours, and this angle is covered in rest 10 minutes. So we can say the y is equal to rotation in h hours plus m minutes. We know in 1 hour there are 60 minutes. So first convert this h hour into minute, which is h into 60. Here we use the formula distance is equal to speed into time. So y degree is equal to 60h plus m. This is time and this is speed of hour hand, 0.5 degree per minute. After solving, y is equal to 30h plus 0.5 m. Now calculate the rotation of minute hand, which is x. X degree is equal to rotation in m minutes by minute hand. Again, the formula of distance is equal to speed into time, m into 6 degree per minute. The x is equal to 6m. Here in first case, theta is equal to y minus x, and in second case, theta is equal to x minus y. So, theta is equal to y minus x. Here we find the absolute value of theta. Here, this y minus x is equal to 30h minus 5.5 m, we can write this 5.5 m as 11 by 2. So the final answer is theta is equal to 30h minus 11 by 2 m. Here, this is our main formula. First question, find the angle between the hour hand and minute hand at 10 hours 15 minutes. Here, put h is equal to 10 and m is equal to 15. Now, theta is equal to 300 minus 82.5, or theta is equal to 217.5 degree, or 360 degree minus 217.5 degree, which is 142.5 degree. Here, this angle is 217.5 degree and this angle is 142.5 degree. Question number 2, find the angle between hour and minute hand at 2 hours 25 minutes. Put h is equal to 2 and m is equal to 25. The theta is equal to 60 minus 137.5, which is 77.5. Here is a very interesting question. How many times in a day the angle between the hour and minute hands of a clock is 180 degree and 90 degrees? Case 1, the angle between hands is 180 degree. In general, hour hand and minute hand of a clock make 180 degree once per hour. The total number of 180 degrees should be 24 into 1 is equal to 24, but this is not right. Because in the duration of 5 o'clock to 7 o'clock, this condition of 180 degree occurs only once, which is at 6 o'clock. This happens in both the cycle of 12 hours. So the total number of 180 degrees are 24 minus 2 is equal to 22. The second case of 90 degree. In general, both the hands of a clock make 90 degrees twice per hour. So according to it, total number of 90 degrees should be 24 into 2 is equal to 48. But it is not right. Because in each cycle, from 2 o'clock to 4 o'clock and from 8 o'clock to 10 o'clock, this happens only 3 times instead of 4. Or we can say 2 90s are missing. 2 90s per cycle, and there are 2 cycles of rotation. So 2 into 2 is equal to 4 90s are missing. So the final answer is 48 minus 4, which is 44. So we can say the hour hand and minute hand of a clock make an angle of 90 degrees 44 times a day and 180 degrees 22 times a day. Faulty clock. There are 2 types of faulty clock. First is fast or time gaining clock. Second is slow or time losing clock. If a clock indicates more than the real time, then it is a fast or time gaining clock, and if it indicates less, then it's a slow or time losing clock. A fast clock covers more than 2 cycles of 12 hours per day, and a slow clock covers less than 2 cycles of 12 hours per day. Coinciding time or overlapping time. As we know, at exact 12 o'clock, the hour hand and minute hand coincides. And we have to find after how much time this thing happen again. Here we use this formula, theta is equal to 30h minus 11 by 2 m. Here h is equal to 12 and we have to find m, and theta is equal to 0 degree, means both the hands coincides. After solving, m is equal to 65 and 5 by 11. Here we can say the hands of the clock coincides every 65 and 5 by 11 minutes. Case 1. If the coinciding time of a clock is less than 65 and 5 by 11 minutes, then that clock is fast or time gaining clock. Case 2. If this coinciding time is greater than 65 and 5 by 11 minutes, then that clock is slow or time losing clock. Here is your homework. Between 4 o'clock and 5 o'clock, the hands of a clock make an angle of 90 degree twice. What is the interval between these 2 times? The solution of this question will be discussed in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update.